Hi, dual enrollment college algebra. This is Miss Backfish, and we got cut off by the bell today in class, and we were in section 4.3, which is in the middle of our exponential and logarithmic functions unit. And so we were doing all this stuff with properties of logs, and I told you I would go ahead and make a video. So this is 4.3. I'm probably also going to make a video for 4.4. 4.3 is basically just dealing with all the different properties of logarithms. And because we had done this in, problem by problem, I decided it might be good for us to just look at them all in one place. So I made a little sheet that shows them all the ones we've talked about here. Okay, so I am calling these properties of logarithms, but honestly, some of them are not traditionally called that. They're like maybe the definition of a logarithm or just characteristics, but that's okay. We're just going to lump them all under that title. The very first thing we talked about doing is rewriting. Rewriting is taking a logarithmic equation and rewriting it as an exponential, or notice this goes both ways, taking an exponential and rewriting it as a logarithm. Usually we do this because it makes it easier to solve. So always consider that that's an option if you're trying to solve a logarithmic equation or an exponential equation. Really, that's the reason we need logarithms, is so that we can solve exponential equations. Logs are the inverse of exponentials. Then the next two things were just some notation things. If you see a log with no base shown at all, it means log base 10. And that's one that's on your calculator. So that's a convenient one to use sometimes. If you see ln, that stands for natural log. So that's log base e. And again, that's one that's on your calculator. So it can be very convenient to use that. Now, the properties. This one is, I don't know that it has a name. But this one basically, if you have a logarithmic equation and your base of the log and base of your exponent match, where you have an exponential expression as your argument. The thing you're taking the log of is considered the argument, the thing that goes right here. Okay, so if you have the base of the log and the base of an exponent, and they are the same number, then the whole thing just equals x. That's easy enough to prove by rewriting. And with that goes this. Same idea. If you have base of the exponent, base of the log, they match, then this x is just my answer. That the whole thing boils down to just x, not log of x, just plain x. Here we get to what are really usually considered the properties. The product rule, the quotient rule, and the power rule. Notice key thoughts here. It's a single log when it's a product, and we can change that into a sum with two separate logs. Okay? Has to be the same base, always the same base. So log of a product equals the separated individual logs of the two things being multiplied added together. Log of a quotient can be separated into subtraction. When it's in subtraction, it's got two separate logs. When it's just the quotient, it's only one log. And finally, the power rule says if you have the log of something to an exponent, you can move that exponent out front. Okay, and very often we have to when we're trying to deal with logarithmic expressions. What we're going to do with these, what we do with these a lot of the time, is we simplify or expressions, and you could think of it as simplifying or not necessarily, but we go two directions with it. We take them and we unravel them, which is kind of going in this direction. It's all nice and compact, and we unravel it. Or we go this direction, it's all spread out, and we put it back together. Going from here to here is called expanding. Same here. Okay? Going the opposite way is usually called condensing, although sometimes it'll be stated as write the expression as a single logarithm. And that's just referring to the fact that you only see the log, log, once when it's in quotient or product form or exponential. Okay? Now, in terms of how to do it, well, let's get into a couple of examples and we'll talk about how that works. First of all, you guys already we did A and B here on this page in class. We also did C. So we needed to pick up at D. Unfortunately, I just recorded this whole video once before with the sound not working. So my D is already done, but let's pretend it's not. Okay. Let me just do this. Sorry. All right. So here we go. And if you need to see the other ones, here's A and B and C. Okay, so this is condensed basically. This is in its most compact form. And so we are expanding, and that's what the directions say, expand. When you are expanding, think about an onion and how it has layers, or think about, it might be better to think about terms of a person putting on a bunch of clothes in the winter. You know, they put on long underwear, and then they put on a shirt and pants over that, and then they put on a coat and a hat, and etc. Well, when you are expanding, it's like you are pulling all that stuff back off after you come in out of the snow. First you take off the hat and the scarf, then you take off the coat. You can't take off your shirt until you've taken off the coat. Then you take off the sweatshirt, etc. So you got to start with the outer layers. What I'm getting at is when we do this, we kind of do reverse order of operations. Order of operations, PEMDAS, right? We would take care of, our exponents first, and then our multiplication or division. And we have both of those here. We have multiplication up here. We have division here. All right. If we're trying to peel off the outer layers of the onion, we got to do the opposite. We've got to go in the opposite form. First, I need to get rid of this division before I can address what's going on in just the numerator with multiplication. So I'm going to do the quotient rule first. Division turns to subtraction with separate logs. Then I'm going to take care of this multiplication. So multiplication turns to addition with separate logs. And then the exponents are going to come last. Okay, so exponents, we just move them out front. Sorry, my table is shaking a lot. And that's my answer. This is an expanded form. So if I were going in the opposite direction, if I were trying to go from here to here, condensing, the last thing we did here was we addressed the exponents. They would come first, going the other way. Okay, so let's look at that. And again, I already started this a little bit when I was doing my video that the sound didn't work on. Same exact properties. These are not different. Same properties. We're just going to use them in the opposite order. This is expanded. It's a sum. So as you can see here, I said I need to take care of this first. The sum rule, it doesn't account for having things out front. So I can't use it when I have things out front. So dealing with that exponent is the first thing I do. I pop it up in the exponent, and I'm done with that. Then I'm going to deal with the addition and change it to multiplication with a single log. So log of, this is x times y to the 7th. And you don't have to write it quite like that. You could write it like this, or you could parentheses. But any of those are fine. Notice that the base here is 10. Next up, numbers out front get taken care of first because they need to go up in the exponent. So we've got natural log of x to the 7th minus natural log of y to the 3rd. Next, I can deal with the fact that it's subtraction. So I invoke the quotient rule. And there we go. Remember that logarithms, what they are is they're inverses of exponentials. So let me point out, the whole multiplication goes with addition thing, and division goes with subtraction thing. That's no different than when we were dealing with exponential rules in Algebra 1. Multiplication, sorry, this is an M. This needs to be at the same base. Multiplication becomes addition. Division becomes subtraction. So it's related. That's why that's true. Okay, it doesn't look exactly the same because it's a different scenario. Next up, we have numbers on front. Those are always going to be the first thing we deal with. So natural log of x to the 4th plus natural log of y to the 7th minus natural log of z to the 3rd. Now, what do we take care of next? Because what comes first, addition or subtraction? Think about order of exponent, order of operations. Remember that even though we say addition then subtraction when we say it, they come at the same time. Addition and subtraction happen together. Multiplication and division happen together. It's just left to right. So we're going to take care of whichever one comes first, going left to right. It's addition, so I make this multiplication. Now it's subtraction, so I'll make it division. And we're done. Okay, same thing over here. I don't see any numbers out front, so I don't have anything to pop up into the exponent. But I have addition and subtraction, and we're going to take care of it as it comes, a pair at a time. Addition becomes multiplication, so log of, and I'm going to leave it like that. I'm not going to distribute, and you'll see why in a little bit. Next, I'm going to take care of that. I probably need more paper here. We cannot be tempted to say, oh, let me put these two together and then I'll put it together. It has to be left to right. So the next pair that I put together is this and this. It's subtraction, so it's division. Log, or it becomes division rather. Okay, so now we have subtraction again, so it's division again. So we need to remember how we divide fractions. If you have, we're going to be dividing all of this by this. If you divide a fraction by just another number, okay, first thing to remember is that this means over 1, right? And dividing fractions, you multiply by the reciprocal. Some people call that keep change change. Okay, but that's how we would do it. So here we're going to be multiplying this fraction times the reciprocal of this. In other words, it's like, here's my a, x times x squared minus 4. My b is 15. So it's going to be times 1 over x plus 2. Let me write it all out. It's like, wait, I thought subtraction was supposed to be division. This is division, remember? Division is, with fractions, multiplication of the reciprocal. So that's what's happening here. Let me go ahead and use this sheet to keep going. Because this can simplify. This is why I didn't multiply this out, is to simplify a fraction, we divide, or excuse me, we divide out, or you could say cancel, common factors. So let's look at what's on top here. When we multiply two fractions, we do top times top, bottom times bottom. So on top here we have this. What did I just do? I factored x squared minus 4. It's a difference of two squares, x plus 2 times x minus 2. If you don't believe me, multiply these out, use FOIL or distributive property, and you'll get x squared minus 4. In the denominator, we have 15 times x plus 2. This is why I didn't multiply it out, because I knew, or I had a sneaking suspicion, that that was going to cancel when I saw that this was x squared minus 4, which I know is x plus 2 times x minus 2, and this was x plus 2. So we have x times x minus 2 all over 15. So it's still got a log out front. So it's log of x times x plus, excuse me, x minus 2 over 15. If you really wanted to, you could go ahead and do that if you wish. Same thing. Both of those are just fine, either way. There's my answer. So that one was a little bit more complicated. So that takes us to the end of section 4.3, which is properties of logarithms. And next up, we're going to be looking at equations, solving exponential and logarithmic equations. We need those properties to be able to simplify things to make them easier to solve. Thanks for watching.